Okay, today's lesson is talking about correlation. So today you're going to learn about what is an R value. Okay, so correlation is us just connecting two statistical items together. So sometimes two variables are connected to each other. Sometimes they're connected in a positive way, sometimes in a negative way, and sometimes they might not even be connected to each other. So some just thinking, correlation between eating food and getting cancers. Is there a correlation? There might be, there might not be. Probably would it be strong? Not really. Would there be a connection between hot weather and crime? If you did some statistics on it, there might show a little bit of correlation, but it probably wouldn't be that strong. Would you say that there's a connection between making money and the hours that you work? Yes, that would be a pretty strong connection. Would you say that's a positive correlation or a negative correlation? So positive means if one goes up, the other one goes up. Negative would be if one goes up, the other one goes down. It would be a positive. So more than likely, the more hours you work, the more money you would make, right? That would go up, up. Something that would have negative correlation. Can anybody think of anything in life that would be something would go up, but then something would go down? Okay, what about if the temperature increases and hot chocolate sales? Would that have a negative relationship? Or how about this? Hours on screen time. Grades at school. Okay, R values. The R values can go anywhere from -1 to 1. So if I kind of draw like a number line, if you had a strong connection, your R values would be close to 1, like 0.9. Like whatever, that would if it was 0.9, that would show a very strong positive relationship. Or -1, yeah. So yeah, if it was like -0.9, that would show a very strong negative correlation. And if you have something that's a weak correlation, it would be something like a 0.1 value, or a 0.2 value, or a -0.1, or a -0.2. Does my chart explain it enough? Strong connection means you're closer to those values. Weaker is that you're not close to those, as close to those values. So in your booklets now, we're going to flip to your pink formula sheet. So this is the R value chart. So N means how many sample sizes you did. So when I talked about screen time and grades, if I only did my experiment with 5 people, this is what N would mean. N is just how many pieces of stats that you gather. Okay? In statistics, this is how it works. The more data you collect, the more accurate you would be, right? Does that make sense? The less that you collect isn't as accurate as a description. Okay, so let's looking at the chart as we go up. the R values are going down. Okay, so what does this mean? The more pieces of data I can collect, I don't need as big of an R value to show that there's a relationship. If I only collect a few things of data, I need a really high R value to show that there is a connection, because my data isn't very a good predictor necessarily, so then I need a higher R value to show that. So what do I want to say? More data collected equals less R value to show that connection. And then it says, what about a sample size of 1? Well, even not only 1, but there's no sample size of 1, there's no sample size for 2 or 3. So can we just statistically say that those sample sizes just aren't enough to analyze anything, right? Like if I only wanted to see the prediction with hours on your phone and your grades, and I only asked one person, that's not really going to tell me a lot, right? So those samples aren't even big enough to analyze anything statistically. Thank you. Okay, so here's how the chart works. So we're going to go to the n of 22. So on your chart, you're going to go to 22. And then there's these values. So what does this mean? It means that if I'm here, there's a 95% chance that those variables are connected to each other, a relationship. And if I'm here, then there would be a 99% chance that those are connected. So here or above, here or above. So if I'm below this number at all, no relationship between those variables. Okay, so we have a 0.58. So 0.58 is bigger than that one, and it's bigger than that one. So it's showing me that I'm at least this. So there is the percent. So I'm 99% certain that there's a correlation. Okay, so 35 is the next n number. So I'm going to go to 35. And then I'm looking at a 0.36. So the 0.36 is bigger than this, but it's not bigger than that. So I can only be this certain. So that means I'm 95% certain.
The negative doesn't matter?
No. The negative is just on the, like how we do our z-scores, same idea. The data with the positive versus the negative is going to be the same. Okay, so now if I go to a sample size of 50 and there's a 0.25 there, so 50, 0.25 is not bigger than this one, so therefore it's not enough to say there's a correlation at all. So there's no correlation, significant correlation anyway. Okay. So your R values depending on that sample that you're collecting.